Thank you very much. And I think as we're waiting for the slides to come up, I want to compliment the organizers of having this as both the social science and the science community, because what we're about to talk about and the water session is all the interaction. They don't exist separately, and what are those impacts together, and we need to solve them together. So our talk today is going to be about climate change and drought, and the group did not plan this, but we're having a focus on Africa today. As a famous American politician, Tip O'Neill, said, all politics is local, but all climate change impacts and adaptation are local as well. So we want to put it in a case study. So for my brothers and sisters from other continents, some of the messages are the same here as we heard from India. And I also want to point out my two colleagues who are co-authors on this, Reverend Len Abrams and Tim Thomas. Len has been working on the ground in these issues in Southern Africa. We've been working together for 10 years on these problems, and we want to address them. So when we go to drought, it can be very difficult to define. So generally people think drought is when there's not enough water. But the problem is, what does enough mean, and to whom and what? And so that's where the people and society start coming in, and what can we do? So what scientists have done, and we want to get away from our scientists here, is they've conceptualized drought with lots of statistics and other things. But what we want to focus is operational. What is the drought and how does it impact us? And so there are basically 5 types of droughts that we look at. One is the meteorological drought. That's where we're talking about precipitation and temperature in the abstract and how are they changing. But then they hit society through hydrologic droughts, which is impact on rivers and the availability of waters for cities and other use. There's ecological droughts, where the droughts are hitting our natural ecosystems, which are being stretched into areas where they're less productive. There's social economic droughts where those come in. But then one of the more important ones, which I want to focus on today, is agricultural droughts, as we look at food security being such an important part to this invisible 60% we want to focus on. So agricultural droughts is all about soil moisture. And so crops and vegetation only get access to water through their roots, not above the ground. So any water has to get into the root system of the soil system. And so we've heard about this already twice now, is that as precipitation hits the ground, it infiltrates into the soil, and then plants, they transpire when they do photosynthesis. They take water away, and that's called transpiration, and water is evaporated from the soil. So the climate threat is, as we increase temperatures, which all the models are saying are happening everywhere, we're increasing the rate of transpiration and the rate of evaporation. And if we have a heat wave, it even gets more extreme. So that's taking water out of the soil. But then, as we've heard, we're being driven by the change in precipitation. And my two sisters have already mentioned this, in that that's leading to flooding. And so also our discussion early by IPCC was talking about this happening again, is that agricultural droughts are hidden because the temperatures on the crops are going up. The precipitation events are becoming less frequent, but more intense. This intense agriculture leads to less of the water being able to infiltrate in the soil. So even if over the year the same amount of water, the amount of rainfall that is there, but coming in more intense storms, it can't get into the soil, and it becomes problematic as floods, and we don't have access to it. Also, changing seasonality we're seeing in rainfall can also affect when the moisture is in the soil, when the crops and vegetation need it. So as was reported in our interesting open talk on ICBC, all models, all analysis saying droughts are getting worse. I'm not going to focus, but what does that mean? So I want to take a quick look at this, what this means in a study that we looked at in Southern Africa. And this is the only detailed curve I'm going to show like this, but what this is a series of curves looking at the impact of and frequency of rainfall events, and then therefore on the yield of maize crops in Southern Africa, one of the more important crops. The lines on the left-hand side are current climate, and moving over to the right are future climates. And what we see is that curve, we're really worried about the 20-year drought. So at the pinpoint of those two lines is saying that a 20-year drought now, one that will occur with a 5% chance every year, we call the 20-year drought, that's going to lead to about a 25% drop in yields and maize. And that will occur about once every 20 years. Now, in the future, if we go horizontally over, what we see that is the frequency of an event of 25% will now occur much more frequently, and that's going to take place in about 1 in 5 years. So we're going from a 1 in 20-year event, that's going to be happening every 5 years now. Or if we look at it the other way and go down that curve, what was happening once in 20 years where we lost 20%, 25% of crops, we're now going to lose 40% of crops. So are we ready to handle this? So we have greater losses, bad years, and a higher frequency of those. Either way we want to look at them. Now, we talked about meteorological droughts and agricultural droughts. We're going to look at the difference. This is a map of that change of droughts in Southern Africa. This is the meteorological drought, looking at the change in the frequency of the 20-year event. So the 20-year event, you see basically browns, a little bit of reds, and some in between. And so basically they're going less than 10 years. Almost all of Southern Africa is going to see the 20-year drought coming once in 10 years and even worse. Now, this is just the rainfall. Now, look at the change in color when we go to the next slide. This is agricultural drought. This is looking at the yield, because that was just precip. You put that precip now on a warmer climate, and we have even worse conditions. And here are almost all from 8 to 3 years on this slide. So this is the maize belt of the SADC regions of Southern Africa. That is the main staple for pop and for other feeding. How are we going to be able to deal with that? So the question becomes, how do we cope with these trends? Now, generally, commercial farmers will have access to resources, financial, high seeds input, government information, forecast, potential for irrigation. They can maybe adjust to that. But what about the rest? That's what we want to look at. Smallholders. So globally, 84% of all farms in the world are less than 2 hectares. However, those small farmers only account for 1/3 of the world's food production. Where's the food production going on? In the industrialized world, in the north, where there's large farms producing that food, and there's a huge food trade. Now, in Africa, smallholders account for about 80% of the food production, and also the same in Asia. So the small farmers are really important to the food security of sub-Saharan Africa. So when we look at it, why we have this invisible 60% of Africa's population, we're now at about 1.2, and I just heard it's now at 1.4, but 60% of that is rural. And most of those are engaged in rain-fed subsistence farming. So what does this change from a drought every 1 in 20 years to a drought every 1 in 5? What is this going to mean, and how are they going to cope? When we look at this, one of the problems in Africa is Africa has significantly higher costs for irrigation than the rest of the world, particularly in Asia. They don't have the infrastructure that in roads and other civil infrastructures to lead to that, and they don't have the access to water in the right ways. So it's going to be stuck with rain-fed agriculture. Currently, sub-Saharan Africa is importing about $35 billion per year in food, and by 2060, it's forecast to go up to $110 billion. How do we deal with that in our situation? And why are these rural areas invisible? What makes them invisible? They're generally invisible because our economic models that I'm involved in all the time and we generally work on, which we're showing some really fancy results on the right-hand side, they're looking at markets, GDP, suppliers, demands, pricing. Most of the smallholders are subsistence farmers that aren't in the market. We're not seeing them. So they are many times by government looked at as a drain on society. They're not directly contributing to becoming middle income by GDP per capita. And they don't have the access to some of the resources that we have that we need to work on to work on this. So why are they vulnerable? So we have these people that are living in the region, and this is a diagram that was developed by the Stockholm Institute for Water. And what we see are along the x-axis at the bottom is the type of farming system, and along the vertical axis is the availability of soil moisture. And what we see now in our current climate is most of the rainfall, most of the water is above the subsistence threshold, and we're seeing that tail is running into the region which is going into the red. If you look at intersecting the red line into that level, we can see for the current climate only a small part of that is there. So we're seeing maybe 1 in 20 years we're seeing getting into these detailed parts, and so therefore that's going to lead to failed crops. However, in the future, we see that lower graph there of the bell curve. We see significantly more portions of the future will be in that area that is unsustainable, leading to floods. How do we transform this system to make it more like that on the right-hand side where we're putting in systems? How do we bring this up, bring and change the way rain-fed farming is being done in Africa and the rural regions to make them resilient to these droughts? How do we do it? It's going to be costly, but what do we do? So I want to take a quick look at an event that was a successful resilience to a drought that happened many years ago, and that's Nile River irrigation that we see reported in the book of Genesis when we talk about Joseph and the 7 years of plenty and 7 years of drought. There's a famous paper in the water literature by Bonit Mendelbroth where he looked at this system directly. And what we want to look at is how was the response here? So if we look in Genesis there's the discussion of Joseph and Pharaoh. What we see, the first thing is there was a forecast. So one of the things that helps us to be resilient, and can we forecast? So God showed Pharaoh what was going to happen. I don't know our modelers, climate scientists are that good yet. The next thing we need was we have to develop a plan. The plan was seen by Pharaoh, and he was very pleased. We think that Joseph went to MIT and learned how to do planning. Or maybe Oxford, we don't know.
Or maybe none of them.
Maybe none of them. Developing institutions, that's the other thing. Pharaoh appointed commissioners over the land to take a fifth of the harvest during those 7-year abundance. So as the governor of Massachusetts did, appointed a climate chief. And so this is really important. The other thing is they developed infrastructure. Each of the cities had to store their water, had to store their grain locally. They had to build the facilities to store that. And then they implemented the plan. Joseph shored up the huge quantities of grain like sand and seas. It was so much that he stopped keeping records because it was beyond. They did not eat it. They stored it. They kept to it. They kept it in the bank. They didn't use it. And then finally, success needed resources. So the Pharaoh gave his signet ring to Joseph so he could implement that. So, Chief, has the governor given you the signet ring? No, is that what you need? So what do we learn from that? What do we need to do? Drought forecasting. So this is a new exciting group that's working right now in the Horn of Africa and also in Bangladesh. It's called the Jameel Climate Observatory, jointly with University of Edinburgh and a group at MIT, acting early against climate shocks, using all of the information that's available now for that. The other one is a very famous one for Africa and expanded to the globe called FuseNest, the Famine Early Warning System, going and getting us ready, trying to get the right kind of crops, the right kind of things so that we can grow something then, but if we're going to have famine, getting the food there. So forecasting. The other thing is developing a plan. This is out some of the work we've been doing with the World Bank on how do we develop resilient agricultural infrastructure, bringing that plan together. Building infrastructures. This is from the Zambezi, the Zambia and Zimbabwe climate smart agriculture, looking at all these different elements to make the rain-fed agriculture more resilient. You can read all about these things sometimes later. Developing new and innovative institutions. This is the Food and Climate Systems Transformation Alliance. And like we keep hearing, we are in a state of transformation. One of the problems is climate is dynamic, it's changing. How do we do it? What we did in the past is not going to work. How are we going to transform and adapt to what we're doing? So this is one thing. We also need resources to do this. Our priorities are going to have to change. What this shows here is that investments in large-scale agriculture and irrigation, which tend to do it, does not bring the return that you get as we focus on detailed irrigation. So we have a call to action. Smallholder farmers are important. They don't have the access to the resources. Smallholder farmers are often where it's most likely to be hit. And then finally, we have a call from the Bible here, which we say, we shall open wide our hands to our brothers, to the needy, for the poor in our land. And we don't want them to be invisible or forgotten. The needy shall never be always be forgotten. The poor shall not perish forever. So let us not forget these smallholders. Their families, and in Africa, it's 60% of the population. We're called to action now, and it's going to be even more so in a changing climate. So I thank you very much for your attention.
Good.